We are professionals. We are impact-driven. We are CFA Society Nigeria, a member society of the CFA Institute Global Network of Societies. Our mission is to promote the highest standard of practice in the Nigerian financial services industry and provide a vibrant community for our members. The CFA Charter signals the holders' commitment to professional CFA Society Nigeria, a member society of the CFA Institute Global Network of Societies. Our mission is to promote the highest standard of practice in the Nigerian financial services industry and provide a vibrant community for our members. The CFA Charter signals the holders' commitment to professional CFA Society Nigeria, a member society of the CFA Institute Global Network of Societies. Our mission is to promote the highest standard of practice in the Nigerian financial services industry and provide a vibrant community for our members. The CFA Charter signals the holders' commitment to professional CFA Society Nigeria, member society of the CFA Institute Global Network of Societies. Our mission is to promote the highest standard of practice in the Nigerian financial services industry and provide a vibrant community for our members. The CFA Charter signals the holders' commitment to professional CFA Society Nigeria, a member society of the CFA Institute Global Network of Societies. Our mission is to promote the highest standard of practice in the Nigerian financial services industry and provide a vibrant community for our members. The CFA Charter signals the holders' commitment to CFA Society Nigeria, a member society of the CFA Institute Global Network of Societies.
Hello, are you looking for a CFA preparatory school? A tuition to help with your pursuit of the highly prestigious CFA charter? If yes, then First Quartile Professionals is perfect for you. You can join us from any part of the world. We offer online and physical classes. Our pass rate have been higher than the global pass rate in all but one of the last 18 run of classes we have had over the years. At First Quartile, we also adopt a mentoring system to guide candidates through their journey to earn the CFA charter. At First Quartile you get a chance to network with many industry experts. Visit our website or call 0817-607-4526 for further inquiries.
Good afternoon, everyone, and welcome to today's session, Level 2 of the CFA Revision Bootcamp. Today we have two courses, one alternative. Sorry, can anybody hear me?
Yes, we can hear you.
Okay, thank you, ma'am. We have Quantitative Methods by Asana Babangida Umar and Derivatives by Fola Abimbola, 12 to 2 p.m. for Quantitative Methods and Derivatives for 2 to 3 p.m. Thank you for joining. Asana, over to you, please.
Thank you. Okay, good morning/afternoon, everybody. My name is Hassana Babangida. I'll be taking you through quantitative methods. Today we have 2 hours. I think there are about 4 topics, but we'll be able to cover about 3, hopefully, before the end of our 2-hour session. So starting off with multiple regression. Now, multiple regression analysis basically explains the variation in a dependent variable in terms of the variation in an independent variable. What does this mean? So you have a situation where, for instance, you're really wondering what are those things that drive inflation in Nigeria? So if I were to ask any of you, what do you think affects inflation in Nigeria? I'm probably going to get multiple answers. Some people are going to tell me, I think that the depreciation of exchange rates really affects inflation in Nigeria. Somebody is probably going to tell me, I think it's the PMS price that affects exchange rate in Nigeria. Another person will probably tell me, it is probably due to insecurity. So all those various reasons that you're mentioning that would probably affect inflation in Nigeria. All those things are basically your independent variables. They are your explanatory variables because they explain what happens to inflation in Nigeria. Now, inflation is the subject matter here. Because you're trying to figure out what happens to inflation, inflation is your dependent variable, inflation is your Y. So inflation depends on the level of insecurity in Nigeria. Inflation depends on exchange rate depreciation in Nigeria. Inflation depends on the level of crude oil prices in Nigeria. So if crude oil price jumps up to like 1,000 naira per liter, that also triggers inflation. So that's basically what linear regression is, and that is specifically what multiple linear regression is, because you're saying that there are multiple things that affect inflation in Nigeria. That's where the name multiple comes. So we've talked about the independent variables, which explain the variation of the dependent variable. In this case, our crude oil price, our PMS, our insecurity, exchange rate. Then our dependent variable is what we're trying to explain. So the next thing is slope coefficient. So let me just use my pen. So typically what you would see, let me see if I can. Okay, so typically what you would see in your regression is you would see y equals to alpha plus beta x. Let's say this is beta 1, and let's say beta 2 x2. In this case, beta 2 can be your exchange rate. In this case, beta 1 can be crude oil price. And rather, X can be crude oil price, X2 can be exchange rate. Now, beta in this case is what you call the slope coefficient. So remember you said, I believe that crude oil price or PMS price is going to affect inflation. But the question is, by how much does PMS price affect inflation? This is what beta captures. So if you say, I believe that maybe about 20% of inflation is coming from PMS price, this is exactly what your beta is measuring. That is your slope coefficient. So it is basically telling you that for instance, for every 1 unit change in PMS price, inflation is going to change by about 20%, assuming, let's say, beta is 20%. So that is simply what your beta does. The same thing for this exchange rate as well, the slope coefficient for exchange rate. The slope coefficient for exchange rate is also telling you the same thing. It's telling you that for every change in exchange rate, beta is basically how much inflation is going to change in Nigeria. It is basically quantifying what you're thinking. So we're moving from just saying, I think PMS is going to affect inflation. You're now moving into quantifying it. That is simply what your slope coefficient does. So whenever you see a question that requires you to do any form of interpretation of your slope coefficients, that's how you go about it. Then we have our intercept. The intercept here is assuming, let's say everything here, by the time you put everything to 0, so let's assume there's PMS price does not affect inflation. Let's assume this is 0, this is 0, exchange rate is 0, PMS is 0. So you find that there is something that still triggers inflation in Nigeria. So it is that level of inflation that is there, regardless of what it is. So it could just be that, for instance, as a supplier, no matter what, you feel like you want to make profits, you might want to still increase your price, even if it is by 500 naira. This can basically be your intercept. So the intercept is the change in dependent variable, assuming no change in independent variables. So assuming there's no change in your PMS price, assuming there's no change in exchange rate, so these guys disappear. This is the change in inflation. Please, are we together so far? And I hope I'm not too fast. Oh, there's a chat box. So, okay, that's fine. And so the next thing is assumptions. So these are the assumptions for, these are the assumptions for linear regression. So linearity, as the name implies, multiple linear regression. The relationship between the dependent and independent variable is linear. That's one of the key assumptions of a multiple linear regression. The next one is homoscedasticity. As I would always explain, homo means same. So how you would remember is same. Then this skedasticity is basically variance. So when you see this, you just know that it means same variance. So the assumption is that the variance of the residuals should be the same for all observations. So let's say that you have a line. You want a situation where the variation between the residuals should be constant. There shouldn't be a situation where you are having some residuals at this point and then some residuals at this point. You can see that the variation is much larger, but you want a situation where the variation of the residuals is basically constant, and that's why it says you want the same variance. Of course, what is it called? Violation of this assumption will be heteroscedasticity. Hetero meaning different. So when you see a question that is asking you, what is a violation of same variance, or what kind of violation is this? And you see heteroscedasticity and you see homoscedasticity. Homoscedasticity is not a violation. It is the main assumption. Hetero simply means different. So different variants. And once you see heteroscedasticity, you know it is a violation of multiple linear regression assumption. And then the next thing is independence of errors. The observations are independent of one another. This implies that the regression residuals are uncorrelated across observations. So you don't want a situation where, for instance, here we had earlier said PMS price, and then we said exchange rates. You don't want a situation where the residuals you don't want a situation where the residuals are correlated between exchange rates. So you have another value here, which means residual. So there are some things that you might not have captured actually in your model that are being captured by this error, the residual. So you want a situation where the observations are independent of one another. You don't want the residuals to be correlated, for instance, with PMS price. You don't want the residuals to be correlated with exchange rate because it's going to affect your regression results. So that is what you have as independence of errors. Then, of course, the final assumption is normality. The regression residuals are normally distributed. That is the final assumption that we have here. Do you have any questions so far? Okay. I can't seem to see the chat box. I don't know if there are any questions. Hello?
Can I hear you, ma'am?
Okay, so let me just keep going. Okay, so the next concept we'll be looking at is standard error of estimate. The standard error estimate for regression is the standard deviation. Okay, so we're looking at ANOVA, first of all, analysis of variance. It's basically a procedure for analyzing the total variability of the dependent variable. We're going to look at that in details. So the first thing here is the total sum of squares, which measures the total variation in the dependent variable from its actual mean. So as it says, total sum of squares. So you basically want to know what is the total variation of your dependent variable? In this case, we've said inflation. How much does inflation vary from its mean value? So how much does actual inflation vary from the average level of inflation? Let's say the average level of inflation over the last 5 years versus the actual value of inflation. How much does that vary? That is measured by your total sum of squares. And as the term implies, sum of squares, which is why you're seeing sum and which is why you're seeing squares. So that's just one way to remember it. And you know that it's just talking about variation. Anything that has to do with variation, it is simply taking the difference between something and something. So you can see it is taking the difference between the actual value. This I here represents the actual value of y, and then the bar, y bar represents the mean value of y, and then you take the squares. The sum of squares regression measures the variation in the dependent variable that is explained by the independent variable. So this basically means the deviation in the predicted value. So earlier we looked at a situation where you have your y, your alpha plus beta x. Let's say that's x is PMS, and then you have beta 2. What this regression gives you is an estimate. It basically gives you an estimate of how much crude oil price or how much PMS price affects inflation. And that estimate is represented by this hat. It gives you an estimate of how much PMS price affects inflation. This estimate is y hat. So that's why you're seeing y hat. So the difference between y hat and the mean value, that is your regression sum of squares. Then the mean sum of squares is basically your regression sum of squares. Of course, you know, whenever you see a question that is telling you what is the mean, you know, all you're doing is you're dividing by the total number. And that's simply what you're doing here. All you have to do is divide by n. And what is n in this case? N in this case is, well, I said, I believe that PMS affects inflation. I believe that exchange rate affects inflation. So it's simply divided by 2. So the number of independent variables, that's your mean squares regression. Then you have sum of squared errors. Now, sum of squared errors is just telling you that, okay, if I do my regression estimation, I believe that, for instance, PMS price affects or contributes to inflation by some level. Exchange rates contributes to inflation by some level. So let us say that at the end of the day, I believe that maybe the estimated value of inflation, when I take into cognizance PMS price, when I take into cognizance exchange rate, let's say inflation is about 25%. But when I now look at the actual number that NBS has released, which is about 30, I don't remember the number, it's about 30 something percent. So let's say it's 30%. That's the actual number of inflation. So this sum of squared error, as the term implies error, it captures the error in what your regression has brought out for you, which is the estimated value that the regression brings out and the actual value. And that's what you have here. So this is the actual level of inflation, what NBS has released, versus what your regression model is telling you. Your regression model is telling you, see, if you capture exchange rate, if you capture PMS prices, if you capture insecurity, I believe that inflation is going to be 25. So your sorry, I think I got disconnected. Okay, are we still together?
Yes.
Okay. I don't know if you have questions. I think you may be able to just speak honestly, because it's difficult for me to be checking the chat box. If you have questions, if you think I'm going too fast, you can interrupt me. Okay, so we're talking about the sum of squares errors. So that's essentially what your sum of squares errors capture. The difference between the actual value that has been released and the predicted value from your regression. And that's what you have here, essentially. That is basically what you have here. Y minus y hat. And then, of course, it has squares because it's error. So total variation is basically the explained variation plus the unexplained variation. Note that the sum of squared errors is the same as unexplained variation. Sum of squared regression is the same as explained variation. So if you sum up these two, you get your total sum of squares. Okay, and then we have your standard error of estimate. And you know, like everything that you know, whenever you see a question that is telling you to find the standard deviation, you would always just take the square root, and that's what you have here, the square root of mean squared error. Your coefficient of determination is basically the same as your R squared, and it is basically the percentage of total variation of the dependent variable that is explained by the independent variable. So you typically see a normal regression output that can tell you, okay, R squared, let's say, is 0.65. This is just simply telling you that the total variation in inflation is actually explained by PMS price and is explained by exchange rates, which are your independent variables. That is typically how to interpret your R squared. Do we have any questions so far? Okay, so we don't have any questions. And then you have your adjusted R squared, which basically helps to overcome the problem of overfitting. So by the time you have too many independent variables, and again, this adjusted R square really just comes from your regression output. So when you run a regression, it actually comes up, and this is the way that you go ahead to calculate your adjusted R squared. I don't know how to help you memorize this particular formula. I really am not one for cramming, but I think this is one of the formulas that I'll probably just cram. Then we have our F-test. So F-test assesses how well a set of independent variables explains the variation in the dependent variable. Now, the way the F-test is that you might have a situation where you have a full model and a restricted model. So the way it is that your full model has a higher number of independent variables and your restricted model has a smaller number of independent variables. So let's say your full model has A, B, C, D, E. This is your full model. Then your restricted model probably has just D and E. So what you find is that D and E is nested within your full model. So what you have essentially excluded is A, B, C, and that is what is captured by Q here in your formula. So essentially, that is what your full model and your restricted model is. So restricted model always has a smaller number of independent variables. Your full model has a larger number of independent variables. So how do you go about your calculation? So you have your sum of squared error, which we've looked about, which we've looked at before. This is your sum of squared errors here, which I said is basically the difference between the actual value and the estimated value in your regression. So you take the difference between the sum of squared error of your restricted model and your unrestricted model, and they will typically give you this. It comes out in your regression estimate. So you're not likely going to be calculating the sum of squared errors. So you're just going to see your restricted model and unrestricted model. And like I said, your restricted model has smaller number of independent variables. So you just have to look at the table and figure out which one has the smaller number of independent variables, and that's basically your restricted model, and then you divide it by Q. So Q is the number of excluded variables in the restricted model. So for instance here, you've been told that your unrestricted model has 5 variables. Your restricted model has 2 variables. So it simply means that you have excluded 3, 5 minus 2. So Q is going to be 3. And then you divide it by your sum of squared error by the unrestricted model. And n minus k minus 1 is basically the degree of freedom. Do you have any questions on this? Assuming everybody is fine. So the next one is for evaluating a regression model. Regression outputs may include the AIC and the BIC. So essentially, what you simply want is that you want whatever you want AIC to be as low as possible and BIC to be as low as possible. That's simply what you're looking at in this case. When you see a question, you're just looking at which model has a lower AIC or which model has a lower BIC. So lower values indicate a better model under either criteria. So if you have two models, you've been given a question, you have two models and you've been asked, which model is a better model? You look at the AIC of one model, you look at the AIC of the other model. Which one has a lower AIC? That is basically the better model. Now, AIC is used if the goal is to have a better forecast, while BIC is used if you want a better goodness of fit. So you might get a question that is asking you maybe which model, based on the two models, which model has a better goodness of fit? Better goodness of fit, better goodness of fit, which is basically BIC. So you're going to be looking at BIC. Which one has the lower BIC? That is what you're looking at. If they ask you which model is going to give me a better forecast, you're going to be looking at AIC. Which one has a lower AIC? So modeling specification. It requires that the chosen independent variables have an economic rationale, that the model is parsimonious, and that the regression's functional form is correctly specified. So for instance, you're trying to look at, again, determinants of inflation. So maybe you believe that economic growth affects inflation, but instead of putting maybe GDP growth in percentage, you decide to put GDP growth as it is in nominal values, which is in billions of naira. This might affect your model specification. That is basically what it means. Or do you have an economic rationale for putting, for instance, insecurity in your model of determining inflation? Does it really make sense to say that insecurity affects inflation? Yes, it makes sense to say that insecurity can affect food prices. Okay, another thing, do you believe that it makes sense to put exchange rate as a determinant of inflation? Yes, I believe it makes sense to put exchange rate as a determinant of inflation. So those are things that can affect your model specification. Okay, so we have different types of violations. So remember, we talked about regression assumptions. Now we want to look at those things that result in a violation of the regression assumptions, or simply regression assumption violations. So you have something called unconditional heteroscedasticity and you have conditional heteroscedasticity. Remember what I said before, hetero is just basically different variants. So in terms of unconditional, you can think of conditional as and unconditional as, imagine a situation where I tell you that your results does not depend on something, or your results depends on something. So in terms of this conditional, it is just basically telling you that the error variance is basically correlated with the values of the independent variable. So it is conditional on the independent variables. So for instance, you have your alpha, you have your exchange rate, you have your PMS price, right? And then of course you have your error. So what this simply means is that you're saying that the error in PMS, in measuring PMS, for instance, of course, you know that this regression only gives you an estimate. So the error in measuring PMS, for instance, depends on the error in measuring exchange rates. So it is most likely going to bias your result. It is going to affect your results. Because, for instance, if PMS has a larger impact on inflation, it means that it is probably going to be affected by exchange rates because they are linked together. So if PMS maybe has a larger coefficient, it is going to go and affect the coefficient of exchange rate. Are we together?
Yes.
Okay, thank you. So that's basically what conditional heteroscedasticity.
Can you say that again, please?
Okay, so I was trying to distinguish between conditional and unconditional heteroscedasticity and why conditional heteroscedasticity is a problem. So what I was trying to say is that basically with conditional heteroscedasticity, it simply means that if I say that PMS prices, right, affect inflation in Nigeria, and let's say I believe that it affects inflation by maybe 0.2, and exchange rate affects inflation by maybe 0.3. If there's conditional heteroscedasticity, you find that the impact that PMS is having on inflation, it is going to be correlated with exchange rates. So that is going to affect your estimates. And that's a problem. So because they are related to each other, so that's why you see here exists when the error variance is correlated with the value of the independent variables. So if you're measuring, if there's any error in measuring PMS prices, for instance, so you believe that PMS price affects inflation by 0.2, but in actual sense, maybe PMS price affects inflation by more. Let's say it affects inflation by 0.5%. So that is captured by your error, right? The actual versus what the regression actually gives you. But what you now find in conditional heteroscedasticity is that this error that you've captured for PMS, it is going to be correlated with the error that you're going to capture for exchange rate. So it is going to be distorting your result. So your standard error is going to be affected because it has to do with error. Your standard error is going to be affected. How is your standard error going to be affected? It is going to reduce your standard error. So your standard error is going to reduce. And what do we remember in your calculation of T statistics? I don't know, can somebody remind me how to calculate T statistics? Does anybody remember?
Coefficient over your standard error.
Coefficient over standard error. So if standard error is lower, what does this mean for this formula?
Type 1 error.
Thank you. So this goes up and you're going to have type 1 error. Why do you have type 1 error? Because your T statistic is going to be larger, right? So if your T statistics would have been, let's say, 0.5, now your T statistics is probably going to be 2. The larger your T statistics, the more likely is going to be larger than your critical value, the more likely you're going to reject your null hypothesis. You're going to have type 1 error. Is everybody okay with type 1 error?
Yes.
So everybody's okay with type 1 error. Okay, that's fine. So that's conditional and unconditional heteroscedasticity. So that's why conditional heteroscedasticity has it breeds a problem. Now, it can be detected using the Bruch-Pagan test. These are key things that you need to try and remember. The method of detection, what is going to lead to. So we've said that conditional heteroscedasticity is going to reduce your standard error, is going to inflate your T statistics, is going to lead to type 1 error, but you can detect it using a Bruch-Pagan test. How do you calculate your Bruch-Pagan test statistics? Is basically your sample times R squared. Your R squared is going to be given in your model. So they would always give you your R squared. You look for your R squared, you simply multiply it by the sample size, which is n, and that gives you your Bruch-Pagan test statistics. You compare it with the chi-squared, and then, of course, you reject the null or you fail to reject the null hypothesis, and you find out if you have conditional heteroscedasticity. Then you have multicollinearity. Multicollinearity is basically a situation where you put in variables that have a high level of correlation. So for instance, I decide to, again, I'm trying to measure inflation, and then I put in PMS price. Then I put in crude oil price. Then I put in diesel price, that's AGO. Then I put in diesel. I even put in gas prices. Do you think that these variables are highly correlated?
Yes.
So because they are highly correlated, you're likely going to have multicollinearity. And the interesting thing is now a lot of these software packages, they are very smart. So whenever you put certain variables, it can even pick it up and say, oh, there's high level of collinearity. And another thing is that when you even test for the correlation using normal correlation, you would see the correlation between two of them. If you do a correlation matrix, for instance, you might see that they have high level of correlation between themselves. So what does multicollinearity result in? It results in inflated standard errors, reduced t statistics, and then what? What type of error would this result in?
Type 2 error.
Type 2 error. So that's basically it. So you know that.
I have a question.
Yes, please go ahead.
Okay, so when we say we reject or we accept a null hypothesis, null hypothesis is that is usually that it's not statistically different from zero. So for instance, now if we are checking for heteroscedasticity now,
Yes.
and we are saying we are accepting the null hypothesis, does
Yes.
it mean that we are saying that heteroscedasticity exists, or
Okay.
that it does not exist?
Okay, so let me explain how I typically think of null hypothesis. When I hear null, I hear no, first of all. When I hear no, typically I hear no. So in this case now, you know what you want to do, right? You, like you've said rightly, when you reject it, you're saying something is statistically significant. But in terms of heteroscedasticity, you are testing for heteroscedasticity, right? So your null will be no hetero. So sorry, I'm not taking my class from my house, so I'm in Niger State at the moment, so the network is really bad. Okay, let's just continue. Okay, so I was answering a question about heteroscedasticity, the null hypothesis. So what I was basically saying is that when I hear no, I hear no. So in this case, no heteroscedasticity. And no heteroscedasticity simply means homoscedasticity. And then the alternative hypothesis would be that there is heteroscedasticity. So in this case, when you reject your null, when you're testing, if you have your Bruch-Spiegeln test, if you reject this null of no heteroscedasticity, it means you're saying that there's heteroscedasticity in this model. That's simply what you're saying. There's heteroscedasticity in this model, and type 1 error has likely occurred. So what you want is that you want to fail to reject the null. That's what you want for your Bruch-Spiegeln test. I don't know if that's clear.
Yes, it's clear. Thank you.
All right. Okay. So moving on to serial correlation. So regression errors are correlated across observations. That's just basically what serial correlation is. And as I've mentioned before, you find a situation where, of course, you have actual PMS price. Let's say actual PMS price. I'm not sure what the current price per liter is, but let's say actual price is 700 per liter. The regression is probably saying maybe the price is 800 per liter. So you can see that there's an error of about 200 naira per liter. Then the same thing for your exchange rate. Maybe the regression is saying that exchange rate is probably 1,000, but exchange rate is maybe 1,600. There's a 600 naira error. So what happens in serial correlation is that you find that these two errors are correlated across observations. And you know, this is most likely a time series. So maybe what you have is from January 2024 to August 2024. So you find that they are correlated across observations. This error is correlated to this error. This error is correlated to another error across. So this can result in inconsistent coefficient estimates. It underestimates standard errors. And of course, it also leads to type 1 error. So one thing to remember, when you hear type 1 error in terms of this regression violation, you can think of serial correlation. Remember, because the two of them are related to errors. Remember, heteroscedasticity is talking about the variation in the error. The serial correlation is talking about the errors being correlated. So they are both talking about errors. That's one way to remember it. And then remember that both of them have the same implication, which is basically lower standard errors and type 1 error. And it can
Please, can you take that again?
Okay, I was saying that one way to remember this between serial correlation and heteroscedasticity. Remember what I said, heteroscedasticity is talking about same variance, but variance in what? Variance in error. Serial correlation is talking about what? Correlation. Correlation in what? The errors. So both of them are looking at the errors. So you can think of it as one reason why they have the same implication. And that implication is that the standard error is lower. So if the standard error is lower, we've all agreed that it's going to lead to type 1 error. So you can think of serial correlation and heteroscedasticity as having the same implication because they are both looking at errors. That's one way you can think of it, and it can help you remember in exam. So they have the same implication, higher T statistics, lower standard error, type 1 error. You can test them using the same Bruch-Spigan test. But autocorrelation, you can still use Durbin-Watson. So you can see they have a lot of similarities. So now you have to remember one, which is your type 1, and that covers heteroscedasticity. It covers serial correlation. The multicollinearity is simply the opposite of that. Is that clear?
Yes, thank you.
Okay, so positive serial correlation exists when a positive residual in one time period increases the probability of observing a positive residual in the next time period. Negative serial correlation occurs when a positive residual increases the probability of observing a negative residual in the next period. Again, remember, we're looking at these are errors. So maybe if the error is positive in this period, we are likely to see a positive error. That's basically a positive serial correlation. Negative serial correlation means that when this error increases, the next error is going to reduce. We've talked about Bruch-Spigan test. We've not discussed Durbin-Watson test, but it's a way for detecting it. And
sorry, I have a question.
Okay, please go ahead.
Yes, for this serial correlation,
Yes.
are we using Bruch-Spigan or Bruch-Godfrey? Because that was what I saw in the text.
I think it's Bruch-Spigan test. That's what I saw.
Serial correlation.
That's what I saw in the curriculum.
Okay.
But I can confirm, but that's what I saw in the curriculum. You said you saw Bruch what?
Is in the curriculum I saw Bruch-Godfrey.
Oh, okay. I saw Bruch-Spigan, but let me take note of it in my slide. Just a minute, please.
I think Bruce Godfrey is the test for autocorrelation.
Okay, so I'm going to confirm that. I've noted it here in red, and then I'll confirm that immediately after the class. Then I would use it, whatever it is I confirm, I'll put it on the slide so that when they're sharing the slides to you, you would have an updated version. All right. So then we have the variance inflation factor, which is basically used to quantify multicollinearity, and is basically 1 over 1 minus the R squared. You already know what your R squared is. Like I said, this is typically given in your regression estimate. I don't think anybody's going to be asking you to calculate R squared, maybe in level 1. But level 2 now is just really understanding how to interpret, how to even just pick things from that table. So, but the question is, by the time you've calculated your variance inflation factor, how do you even make any decision? So if your variance inflation factor is 1, there's no correlation. If it's greater than 5, it warrants further investigation. If it's greater than 10, it indicates serious multicollinearity requiring correction. How do you correct it? Like I said before, you put in AGO, you put in PMS price, you put in crude oil price. By the way, all these things are derivatives of crude oil. So now you've put in all these things that probably have a high level of correlation. So what do? You can decide to say, well, I can choose to leave crude oil price. But then again, you might say, does it really directly impact inflation in Nigeria? Maybe one way or the other. You can decide to say, okay, let's just leave PMS price. At least you know that this is more direct. Everybody simply goes and buys fuel in their cars, fuel for their generators and whatnot. You can decide to just leave this. So you drop this and you drop this. So that's one way to actually, adjust for serial correlation, or you use a different proxy. So you can decide to say, okay, instead of this, do I do an index, for instance, do I do an index that represents petroleum prices? So maybe my index constitutes of diesel, PMS, and then you put them all in one index and you decide to put them inside, put it inside rather than putting them separately. So that's one way to go about it. So this is basically a summary or functional form model misspecifications. So omission of important independent variable, you have omitted variable bias. So for instance, you're looking at inflation. You might think of, okay, what are those major things that affect inflation? Some people might tell you, if you don't put exchange rate, I feel like you have violated an assumption. So it really depends on what you're trying to do. What is it that would constitute an omission? So based on economic theory, one or more variables that should have been included are omitted. That results in omitted variable bias. It can lead to serial correlation or heteroscedasticity in residuals, and is going to lead to biased and inconsistent regression parameters. Then inappropriate variable form is just basically a situation where, the relationship between dependent and independent variables may be nonlinear. So you might end up putting a variable that is nonlinear. And one of the major assumptions of regression is that it should be linear. That's why it's called multiple linear regression. So you might bring out a nonlinear variable. So what you have to do is you have to linearize it, maybe by taking the logs of that variable. So instead of putting the variable like that, you can take the logarithm of that variable and then it can transform it to a linear variable. So putting a variable that should have been transformed to be linear, that can also be a problem, and it can lead to heteroscedasticity in the residuals. Then you have inappropriate variable scaling. Variables may need to be transformed before estimating the regression. So earlier I mentioned you can decide to say maybe you're looking at inflation and then you put GDP in billions of naira. That might affect your results. Or alternatively, because inflation is in percentage, why not use GDP growth instead? For instance, you can decide to use GDP growth instead. So this is a way of scaling your variable. So inappropriate variable scaling can also lead to heteroscedasticity. So what you will find here is that heteroscedasticity is consistent in all of these different functional form specifications. So that also makes it easier to really understand, because heteroscedasticity is present in every form. Okay, so extensions of multiple regression. Outliers. Outliers are extreme observations of the dependent variable. Again, they are really just extreme observations. So for instance, let us say that, imagine you're looking at, okay, let's say you're looking at the period between 2015 to 2021, and you're looking at crude oil prices. Remember, I believe in 2020, crude oil prices plunged significantly. So you'll find that from 2015 to 2021, crude oil prices were trending pretty normal. Of course, they are volatile. They might go up maybe $60 per barrel, $50 per barrel, and then you come and see crude oil prices at maybe $10 per barrel. That can simply be an outlier because it is significantly different from every other thing. And one thing you need to know about outliers, it is referring to the dependent variable. So why? So whenever you have outlier, it is referring to your dependent variable. In this case, our dependent variable is crude oil price. So what if our dependent variable is inflation? Let us say now, maybe you're looking at inflation this year. We know that inflation this year has been significantly high, but for whatever reason, maybe there was an error and you brought in inflation from, let's say, 2010, and you might find that inflation was probably maybe 10% or even 8%. Imagine seeing inflation at a single digit versus now that inflation is over 30%. You can classify that as an outlier. So that's just basically what outliers are. They're extreme observations of your dependent variable. So you can identify outliers using studentized residuals. Remember, how do you get your studentized residuals? Remember what we discussed earlier. Errors are simply the difference between the actual value and the predicted value. This y hat is basically your predicted value. So the actual inflation in July 2023 versus what the regression is predicting. So that is what this error at the numerator is essentially showing. And of course, this is your standard error. And remember, another thing, again, it's very similar to your t statistics. You know your t statistics, all you're looking at is beta over standard error. In this case, you're simply replacing beta with your error. So you compare this studentized residual to the critical value, n minus k minus 2 degrees of freedom, to determine if the variable is influential. That is it. So you calculate your t, let's say your t is 2.0, and then you look at your critical value. Maybe your critical value is 1.5. If this is greater, you reject, and then you say that there is presence of outlier. Because again, like I said, no, your null hypothesis will be no outlier. Your alternative hypothesis will be outlier. So if you're rejecting, you're concluding that there's presence of outliers in your regression. Do you have any questions on this?
Yes, I have a question.
Okay.
What makes an item depend? What's the actual difference between this dependent and independent variable?
Okay. Thank you. So dependent variable, what you're saying is that this your dependent variable depends on something. It depends on something to exist. It is that thing that you want to investigate. So let us just say you decide you want to know what is it that makes CFA students in Nigeria pass. That can be your question, right? Why is it that CFA students or CFA candidates in Nigeria do better than CFA candidates, for instance, in other countries? That can be it. So your dependent variable will be CFA candidates in Nigeria, because this is your subject. That is what you're interested in investigating. I want to investigate what are those things that affect inflation in Nigeria. Inflation. That is my dependent variable. Now, what are those things that you believe that CFA candidates in Nigeria do that makes them excel? CFA recommends reading 300 hours. Maybe they read 500 hours. So that's one variable. Maybe they probably have a lot of group study sessions. Well, CFA Society Nigeria organizes revision sessions. Maybe other societies do not organize revision sessions. So you've outlined three things. So you're saying that how well CFA candidates in Nigeria do depends on the level of hours they spend. It depends on if they do group studies. It depends on if their society does revision classes. So that is what your dependent variable is. Your independent variable or your explanatory variable is now saying that this number of hours explains why CFA Society Nigerian candidates pass. The number of group study sessions they have explains why candidates in Nigeria pass. The number of revision sessions CFA Society Nigeria holds explains why candidates in Nigeria pass. So that is the difference between dependent and independent variable, or your why and your explanatory variable. I don't know if that's clear.
Yes, thank you very much.
All right. Okay, so you have high leverage points at the extreme observations of your independent variables. So remember, outliers have to do with your dependent variable. That's why. Leverage points have to do with your independent variables, which are your x's. So leverage takes a value between 0 and 1. The higher the value of leverage, the greater the distance and potential influence of the observation on the estimated regression. So the higher the leverage is just telling you that you probably have extreme observations. So in this case, let us assume that our independent variables are, let's say, PMS. So maybe if you look at, let's even talk about exchange rate from last year before the new government. So let's say from last year, maybe as at last year, exchange rate is about 700 naira per dollar, and then now it's going up to maybe 1,600. This is not necessarily a leverage point, but I'm just saying that this could be potentially a leverage point because you're seeing that it jumped from being maybe 700 or jumped from being maybe 600 to 1,600. So that's just basically what leverage is showing you. So the greater the distance between 700 and 1,600, the greater the influence of the observation on our regression parameters. The sum of individual leverages is basically K plus 1. K is simply your number of independent variables, and then you add 1. So if a variable's leverage is higher than 3 times the average, it is considered potentially influential. What does this mean? So for instance, you have PMS, you have exchange rates, you have insecurity. These are your independent variables. You want to see if there's leverage or there are high leverage points in your regression. Okay, so what you can simply do is that you look at the sum of it. So we have 3 independent variables. So that's 3 plus 1, which is basically 4. So if a variable's leverage is higher than 3 times the average, so you have 3 times, of course, this is K plus 1, 4 divided by N. N is 1, 2, 3. So you have 12 over 3, which is 4. So if any variable, let's say you've calculated the leverage of any variable, if the variable, let's say the leverage for PMS is 2, the leverage for exchange rate is 5, the leverage for insecurity is maybe 1. So you can see that 5 is greater than 4. You can now say that exchange rate is potentially influential in this regression because its leverage is higher than 3 times the average. That's basically what that statement is saying. So Cook's distance is used for evaluating if a specific observation is influential. Okay, so values greater than square root of K over N indicates that the ith observation is highly likely to be an influential data point. So you've been given your data sets. think we have, I don't know if we have an example here, but I think we have an example. So it indicates that the ith observation is highly likely to be an influential data point. So you do your square root of k over n, and then any value that is greater than this, it indicates that that particular observation is going to be an influential data point. Generally, a value greater than 1 indicates high likelihood of an influential observation, while values above 0.5 merit further investigation. So these are some of the things that maybe you need to pay attention to. Just simply telling you, oh, is this variable influential? And then you've been given a data set with the Cook's distance, and then you do square root of k over n, and then you see if this value for that particular variable is greater than square root of k over n. So k being the number of independent variables. So let's say you have 5 independent variables. So maybe 5 over the total, let's say 5 over 100, you take the square root, and then you're going to get a table that is going to give you DI for your different observations. And then you come up here. Let me see if I have a calculator to do this 5 over 100 square root. So let's say, I don't have a calculator, but let's assume that this is, let's say 20, for instance. So you look,
0.2236.
thank you, 0.2236, right? So then you go all the way to your table that they're going to give you. You look at and now say, okay, do you have a value that is greater than this? So let's assume now you come to this value and you find that it is 0.5. So you can see that 0.5 is greater than 0.2236. So you can see that values above 0.5, this is 0.5, but let's say 0.51. Values above 0.5 merit further investigation. So you might see a question that is telling you, maybe from the options, you're seeing that, okay, it is influential and warrants further investigation. It is highly influential. Of course, if it is greater than 1, that's when you would say it is highly influential. So if you see 0.6, your option will still remain it warrants further investigation. But if you were to see maybe 1.5, for instance, 1.5 means it is highly influential. That's what you're going to choose as your answer. That's basically what this statement is saying. Are we all good on this? Okay.
Yeah.
All right, so moving on to dummy variables. They are independent variables that are binary in nature. So basically they are assigned 0 or 1. So the simplest dummy variable I'll tell you is, imagine a situation where you want to know, do male CFA candidates perform better than female CFA candidates? That's something you want to investigate, right? Male versus female. This is binary. There are two things you're looking at. So you can decide to say, I'm assigning male for 0 and then female 1. So for instance, you have an observation, you have a bunch of observations, 1, 1, 1, 1. So anywhere you see 1, you know they are females. Anywhere you see 0, you know they are male CFA candidates. So they can be, my point is that these kind of situation can be represented by a dummy variable. Another thing is you can employ a January dummy variable that will take on the value of 1 if a stock return occurred in January and 0 any other month. So you have from January, February, all the way to December. So you can just say that, okay, January is 1. So January 2021, January 2021, you assign it 1. Any other thing, 0, 0, 0, 0, 0. That's just basically what a dummy variable is. Now, the question is, how do you now interpret, dummy variables? So the regression coefficient for the January dummy variable would indicate whether and by how much security returns are different in January versus other months. So let's assume now you have a situation where you have inflation. Maybe you're looking at inflation in other months. So you have your dummy variable, January, or let's say these are stock returns, right? So let's say this D1 is 0.5. So this is basically telling you that stock returns for one change, for one unit change in stock returns, returns in January perform at 0.5% better than any other month, better than February, March, April, May, June. So you're surpassing every other month. So the value that takes on one is what you're going to be explaining. The one that is one, whatever it is that you define as one. In this case, if you have defined females as one, you'll be interpreting this relating to females. Then any other thing you compare it to male. So you can just say that, okay, maybe female CFA candidates are expected to perform 0.5 times higher than male CFA candidates. That's just it. So, but if you have a situation where now you want your male or female to be your dependent variable. So the main subject you're interested in, again, is performance, CFA, performance, male versus female, right? Equal to. And then you have other variables. So what are those things that you think can differ? Maybe, for instance, number of children, maybe the type of work that they do, maybe the income, maybe marital status, for instance, whatever it is, you believe that those are things that can affect your pass rate, whether you are a male versus a female CFA candidate. So something like this is going to be represented using what you call a logistic regression model. Because when you have a qualitative or binary dependent variable, so binary meaning you're looking at two things.
Hello, ma.
Yes.
Sorry, before we leave dummy variable, we are taught that the number of dummy variables should not be complete. Let's say now we are using quarter
Yes.
variables now.
Yes.
You say that means 4 minus 1. The dummy
Yes.
variable is going to be 3.
Yes.
And in the end, the last quarter that you excluded is the value is going to just be your intercept.
Yes, you are correct.
Why? Can you explain? I just know it, but I don't really get why it is so.
So, the way it is that, in a way, it can actually result in, let's just say, think about it as multicollinearity, actually, because you're fitting in January, February, March. You need to be able to compare. Do you get my point? You need to be able to have something as a base to compare. Do you understand? So you cannot fit in January all the way to December inside your model. You have to have a base variable to compare it with. So if you put in all of those variables, it is basically going to result in, let's say, multicollinearity.
That means the correlation will be 1.
Yes.
It will not be less than 1 if we include all the whole variables.
Yes.
Okay.
So you have to now restrict it and use it as it basically represents your intercept. Thank you for that.
Thank you.
Yeah. Okay. So that's basically your logistic regression. So for logistic regression, you use log odds as your dependent variable. So the interpretation of the intercept term in a logit model is similar to its interpretation in a multiple regression. It provides an estimate of log odds when the value of all independent variables, as you remember, when you're interpreting your intercept, you're saying that, okay, this is the value of inflation when every other thing is 0. And because you're using logit, log, so you're interpreting it as log odds. So it gives you the log odds when the values of all your independent variables are 0. Okay? So interpretation of the slope coefficients are interpreted as the change in the log odds of the event occurring per 1 unit change in the independent variable, holding all other variables constant. So typically the way it is that because it's log odds, let's say, earlier we talked about, we said, let us say you have income, you have marital status, and then here you have CFA female versus male candidates. This is basically your dependent variable. So the first thing that you do is that you take 1 over the exponential, and that basically gives you the odds, the probability. So it gives you the probability first. So you have to calculate this first before you go ahead to do your interpretation. Typically, they are going to give you, so you're going to see your question, and in your question, you're going to see the income level. Maybe they might tell you Hasana's income or the people's income is maybe 2,000 naira per month. And then you're also going to be giving the value for the coefficient. So you put everything in, and then you get the exponential and then 1 over the exponential. So that's what you're going to do, which is basically what you're seeing here. That is basically the probability of the event. So when you calculate the probability of that event, you have that done. So the question now is, you now say, okay, assuming income levels now change, you know, I earlier said 2,000. So assuming the income levels change from 2,000 to 3,000. So you come here, you replace it by 3,000. So you see I've increased it by 1 unit, and then you re-estimate. By the time you re-estimate, you now get another value. So let's say the initial value you got was maybe 0.5. The next value you're probably going to get is maybe 0.3. So you take the difference, which is basically the change. So that's why you're seeing the slope coefficients in a logic model are interpreted as the change in log odds of the event occurring per 1 unit of a change in the independent variable. So what you're just saying is that the change is, let's say, 0.2. So this is basically what you're interpreting is that the change in income is going to change maybe the odds of maybe female candidates performing better by 0.2%. That's how you interpret it. It's a bit more complex than your simple multiple linear regression. It's a bit more complex than that. But that's as simple as I can explain it. I don't think I have a question on this log, because the question was very, very long on the curriculum. Okay, so similar to the F-test to evaluate nested models, a likelihood ratio test is used for logistic. This is quite simple. So the log likelihood of your restricted model minus unrestricted model, and then you multiply it by -2. Remember, your restricted model always is restricted, which means it has smaller number of variables, and then your unrestricted model has higher number of variables. Again, very important, your log likelihood ratio, you compare it by chi-squared. So you don't see a question where it's saying like log likelihood ratio. Is it T statistics? What kind of distribution are you using? You're using a chi-square distribution with Q degrees of freedom. Remember what Q is. Q is what you have restricted. So let's say your unrestricted model has 5 variables, your restricted model has 4 variables. It means that you have removed 1. So Q is basically 1. Okay. So this is, I don't know if we can we do this quickly in like 2 minutes? Do we want to do it or should I move on? Hello.
Hello, I know. Just do it and use it to explain further.
Okay, no problem. So remember we talked about standard error of estimate. Oops. Remember what I said about standard error. Whenever you hear standard, remember here it's like doing your standard deviation, right? So you already know you're taking the square root of something. So because standard error of estimate, it means that you're taking the mean squared error. So you take the square root of your mean squared error. That gives you your standard error of estimate. So this is your mean squared error. Sorry, this one. Mean squared error, and then you take the square root. Then when you get a question that is telling you calculate the predicted value of ABC returns if forecast excess returns are 10%, all you have to do is, they've told you that S&P excess returns are 10%. So all you have to do is ABC is equals to minus 2.3% plus 0.64. You put 10%. Can you see S&P? You just replace this by 10%. It's just simple plug and play, and you get your ABC. Then your interpretation. Basically, when you hear log model, it just simply means the dependent variable is log, The independent variable is log, log, log. So that means a 1%, whenever you see log, whichever one has the log, you apply percent to it. So a 1% change in the dependent variable is going to lead to a beta. So let's use let's say this is PMS. And let's say beta is 0.5. So a 1% increase in PMS is going to lead to a 0.5% increase in inflation. If you have a log mean model, it means because this is linear, you use units. A 1 unit change in PMS is going to lead to a 0.5%, because this guy here has percent, inflation has a percent, so you apply percent to it. If you have a lean log model, it means here we now have the percent. A 1% increase in PMS is going to lead to a 0.5 unit increase, in this case, in inflation, because this is linear. That's basically it when you're dealing with interpreting log, lean log, etc. Any questions on this?
All right, it's fine.
All right, so we can move on.
Please, can you solve question 3?
Okay. So what's question 3 saying? Let me move. An analyst evaluates the sum of squared error and total sum of squares from a multiple regression with 4 independent variables to be this and this. A restricted model excluding the last 2 has the sum squared, blah, 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 blah. The F statistics is closest to. So remember the formula for our F test.
SSE unrestricted minus SSE unrestricted.
SSE restricted minus unrestricted divided by Q, and this, that. So that's what we're going to use here. Please, can you repeat the formula?
Minus SSE unrestricted over Q divided by SSE unrestricted over N minus K minus 1.
Right. So you have SSE. So they've told you SSE from a multiple regression with 4 independent variables to be this and this. So they've told you the total sum of squares. So they've told you the SSE, a restricted model. So have sum of squared error. So now they've told you they've already told you that of the restricted model, right? The restricted model has 5105. So you have 5105. The unrestricted model has 4320. Can you see? Then Q. A restricted model excluding the last 2 has this. So they have told you what they have excluded. Isn't that correct? Over 2. Because remember, Q represents what they have excluded, divided by unrestricted, which is 4320, divided by N minus K minus 1. N is 65. K is 4, right? Because the unrestricted has the total number of variables. So minus 4 minus 1.
Please, can you take this number 4 again? I didn't get what.
Number 4. Did you say number 4?
Yes, ma'am.
Okay. So what I was saying about number 4, okay, I didn't even solve number 4, but I was explaining what log and log lane was. The appropriate regression model for a linear relationship between the relative change in independent variable and absolute change. So number 1, they said relative change in an independent variable. So relative meaning percent. So you know your independent variable now is percent, right? Your dependent variable is absolute, which is units. And what I said about unit has to do with linear, percent has to do with log. So you now see that you have a lean log model. Should I go over it again?
Okay, because I was looking at log. Okay, if you say log linear, that means is y that was log and is x that was lean. Okay, that's
Hello?
why B is the answer. Hello?
You are breaking.
Hello, can you hear me? Hello?
Yes, I can hear you. I can hear
What
you.
I'm saying in this question now,
Mm.
the y come before x. That's why B is the answer, but linear
Mm.
log model.
No, that's not why they are. Okay, so let me explain again. So what I
Uh-huh.
said was, whenever you see this kind of question, just pay attention to which one has percent and which one has units. So when you hear relative means percent. Do you understand? When they say absolute, they are referring to units. So now we know that. So now the question says, a linear relationship between the relative change in independent variable. And what do you know? You have your y, you have your x, right? Which one is the independent variable here?
Y. Independent, sorry, x.
Thank you. So you know that they have told you x between the relative change in x. So you know that x has to be percent. Do you agree with me?
Yes, yes.
Good. Now they now said, and the absolute change in the dependent, you know y is dependent, right? So when you hear absolute, you know they're referring to units. So percentage typically is aligned with log. So you come here, you put your log. Unit is aligned with linear. So you have a linear log model. If I were to tell you what the appropriate model for a linear relationship between the relative change in an independent variable and the relative change in dependent variable. So now I know I have y, I have x, right? And I say relative and relative for both. So I know it's percent for both. So whenever I think about percent, I think about log. I think about log. So I have a log model. I don't know if that's clear.
Yes, it's fine.
Okay.
Right, thank you, ma.
Yeah.
Sorry, I didn't get the answer for number 3.
Okay,
I'm
we didn't
getting
even solve the
5.
answer.
Yeah, but
We didn't solve the answer. We just put in the, we just tried to apply the formula.
yes,
We
I
just,
did that and I got 5.45, so I'm confused.
okay, I'm going to try and solve it. So what was your Q?
My Q was 2.
Okay. And what was your, so you have 65 minus,
4 minus 1, that's 60.
and then what do you have as your denominator?
My denominator is the unrestricted, that's 4320.
Okay. So let me, where is my calculator? Let me try something.
Hello?
Hi, I'm still here.
We're not hearing anything again. Okay.
Okay, yes, I was trying to look at this question actually, number 3. So I got the same answer as you. So I'm going to look at the options. I think there's an issue with the options but that's the same formula that you're supposed to use. SS. Yes. Oh, use 9105, please, as your. Sorry, please, 1 minute, guys. Hello? Okay, I'm going to flag the question, and then I would also update that on my slides, please, so that we can quickly move on. Thank you for that observation on that question. So can we go on? Any other question?
Sorry, I tried the other F tests, the joint tests.
Go on.
Hello?
Okay, I'm listening. Yes.
Yes, I used the joint test of slope coefficients and I got C. So I'm thinking maybe it's not the one where you omit the variables. I think
Okay,
maybe
you
it's the
use
one
the
that's supposed to
standard,
test
the original formula from like level 1.
Yes, for the F test.
That is
Because I'm
a
assuming
full
yes,
model.
the full
Full
model,
model.
yes.
But the question is asking for restricted model now.
Yes.
That's from the F test
You
for
know, this
testing.
question, I
No.
didn't pull it. You know, this question, I didn't pull it from the curriculum.
Okay.
So,
Okay.
yes, so it's possible that there's an issue. I didn't pull it from the, I think I just put it from another prep provider, this particular question. Okay, but thank you for that observation. I'll probably just take it off the slide because I didn't even solve it. Okay, so let's move on. If there are no other questions, I don't think we'll have time to go over this. So time series analysis is a set of observations for variable over successive periods of time. So it's just basically saying, you're looking at inflation from, let's say, 2010 to 2024. So you're looking at it over a period of time. That's why it's called time series. So over a series of time period. So the series has a trend. If it has a consistent pattern, that can be seen by plotting the data. So for instance, if you were to carry Nigeria's GDP and you were to plot the GDP, you'll be able to see patterns like this, especially around December. So you find consecutive patterns, maybe, or even maybe inflation. Every December period, you find that there's a peak. There's a peak in economic activities. There's a peak in economic activities. That's just basically what a trend is. It's just telling you that there's a consistent pattern. And you can see that by using a graph. So linear trend models are time series patterns that can be graphed using a straight line. So if you put a straight line, it means that they're just around the straight line. But if I were to put a straight line and then I'm seeing something like this, I can say that they are non-linear because it's going up and down. So if I were to plot somebody's age now, somebody's age might also be non-linear as well. Okay, I mean age square rather. Age square would be non-linear, not age. So when you have a downward sloping line, you have a negative trend. When you have an upward sloping line, you have a positive trend. So used when the variable increases over time by a constant amount. So you use linear trend models when a variable increases over time by a constant amount. And then you have log linear models are used when time series display exponential growth. So it means that this growth is very, very significant. This is when you use log linear models. The data plots with a non-linear curved shape. So when you plot it, you're going to see that it is going to be non-linear. So linear is a straight line, but by the time you plot a non-linear model, you see that it has some curved shape. And it is used when a variable grows at a constant rate. This one is talking about constant amount. Then you have your autoregressive models. So autoregressive models, one way to just simply think about it is that you can decide to say, you know what, I believe that GDP today depends on GDP last year, or GDP in this quarter depends on GDP in last quarter. So let's say GDP today depends on GDP in the last quarter. It depends on GDP maybe in quarter four. So I'll say maybe T minus 4. And then, of course, I can now capture maybe consumption and so many other things. So that is simply what auto-regressive models are. So when the dependent variable is regressed against one or more lagged values of itself. So you can see lagged value of this is the dependent variable, and it is regressed against the lagged value of itself. And yeah, a lot of times it makes sense because you can say that, you know what I'm seeing today might be a function of historic past. So you have to also consider it. GDP today is determined by last quarter's GDP and then a function of other things. Excuse me, please. Okay. So can everybody hear me, please? I think, I don't know why it keeps disconnecting mid-class.
Yes, we can hear you.
All right, thank you. So I was explaining covariance stationarity. I was just saying that time series, one of the conditions for time series is that it has to be stationary over time. So when you plot it visually, even from seeing it, so if you carry the data for inflation or even exchange rate, if you carry exchange rate, you might see that exchange rate is not stationary. It is probably going up. By the time you put the average exchange rate over maybe the last 10 years, you might find that exchange rate is not moving around the average level. If you look at the average, of course, is going to be skewed because now exchange rate is about 1,600. In some cases, maybe 1,700. So that's the new average. But then you can now look at the actual values. Some actual values are maybe below 1,600. Some are above 1,600. So you're going to see that it is not a stationary series. So that's a very, very important condition for time series. So this is just basically an AR model, which is what we've discussed before. So you can see the dependent variable, you can see the lag, an AR model of order P. So all the way to whatever lag it is. So this is called a lag. A lag is just, you're saying something before. If I say, oh, you're operating with a lag, it means that you are too slow. You know, you are still behind. So that's what this is. So you can see this is behind by 1 period. This is behind by 2 period. This lags by 1, by 2, by 3. That's just what the AR model does. So a 1 period ahead forecast for an AR1 model is determined by the following manner. So if you want to do a forecast, so this is, let's say you want to forecast GDP by 1 period. So you can see that GDP for period 1 depends on GDP last year. So you want to see, let's say GDP for quarter 4, right? In quarter 4, that's T plus 4. It simply depends on maybe GDP quarter 3. Now you calculate and you get your GDP for quarter 3. The next thing now you want to know, okay, what is GDP for quarter 1, 2025? So now you've moved further. So you have GDP quarter 1, 2025. It will now be a function of GDP quarter 4, 2024, which is what we have just calculated. So you put this in. So when you see a question that is talking about this and is telling you do a 2 period ahead forecast, you first do a 1 period ahead forecast, and that 1 period ahead depends on the previous past. Then the 2 period ahead would now depend on this one that you've calculated. So I think we have an example. Okay, yep. We have an example here. So when you're told to calculate a 2-step ahead forecast, if the current value is 5, so they're telling you do xt plus 1. So you calculate the current. They've told you that the current, so you want to do xt plus 1 equals to 1.2 plus 0.5 xt. That is what they want you to calculate. That's, you do xt plus 1 first, and then you now go ahead and do xt plus 2. So we can go ahead and look at it here. So you see that 1 step ahead forecast, they have given you that xt is 5. They have gone ahead to give you xt. So they've told you that xt is 5. So you do xt plus 1 equals to 1.2 plus 0.5 xt. And they've told you that xt is 5. You plug in 5, you solve your answer. The next thing is now xt plus 2. And let's assume xt plus 2. What's the answer? 3.45. So xt plus 2 is equal to 1.2 plus 0.45. You plug in this. And that's simply how you do your 2-step ahead forecast. Is everybody okay with this? Any questions? No questions? Okay. So when an AR model is currently specified, the residual terms will not exhibit serial correlation. So how do you check autocorrelation? You estimate your model. You start with a first order AR. You calculate the autocorrelations of the model's residual. And then you use a t-test to check if there are autocorrelations. So of course, the null will be no autocorrelation. So if you're rejecting the null, you're saying that there's no autocorrelation, which is good. That's what you want. Note that the Durbin-Watson test that we used with trend models is not appropriate for testing for serial correlations of error terms in an AR model. Okay. So you are going to use a t-test instead. And how do you get the t-statistic? The t-statistics is simply your estimated autocorrelation. Remember, normal t-statistics is beta over standard error. In this case, it's autocorrelation over standard error, and your standard error is 1 over t. Now, mean reversion. Mean reversion is just simply saying that, for instance, do you think that inflation in Nigeria is mean reverting? Meaning, okay, no matter how high inflation goes, it will come back. And we know there's a lot of sayings that what goes up here doesn't necessarily come down. And, to a large extent, in some cases, it's true. So you can say that maybe market prices in Nigeria might not necessarily be mean reverting. But then some people might beg to differ and say, you know what, I believe that they are mean reverting. So as at a few months ago, if you go to the market to buy 1 basket of potatoes, the price was significantly high. Even though the price is still high, but maybe you're buying potatoes, 1 basket, 20,000 naira. But now you're buying it for less than 10,000 naira. So you can say that the price of potato is mean reverting. It is going back to its previous level. That's simply what mean reversion means. So if a time series is mean reverting, the model predicts that the next value of the time series will be the same as its current value. So what this simply means is that the previous value is going to be the same. So the value of potatoes today is probably going to be the value of what potato was yesterday. So even if potato is 20,000 naira today, I believe that potato is going to go back to maybe 5,000 naira per basket. That's simply what mean reversion is saying in this case. So for an AR model, which of course is specified by this, So for an AR model, which is specified by this, if you want to calculate your mean regression, is simply your intercept over 1 minus your slope coefficient. So if you calculate your mean reverting level, so let's say your mean reverting level is 5, okay? The current value of potato, or let's say the mean reverting level is 5,000 naira per basket. The current value of potato, let's say, is 15,000 naira. per basket. So what this means is that if the current value is higher than the mean reverting level, the AR model predicts that XT plus 1 will be lower than XT. It simply means that it's going to come down. So if the current value is higher, it means that it will have to go down to the mean reverting level. That's what this means. I don't know if I'm clear. If the current value, 15,000 naira, is higher than the average value, for it to come back to the 5,000 naira, it has to go down all the way to 5,000 naira. However, if the mean reverting level, if the current value, let's say, is 2,000 naira, you know that is no way that potato maybe will remain at 2,000 naira. It has to go back up. So if it is low, the model predicts that XT plus 1 will be higher. That's simply what this is saying. So if you see a question that has given you the mean reverting level and has given you the current value, you now think to yourself, okay, if my value is lower than the mean reverting level, it means it has to increase to reach the mean reverting level. On the other hand, if the value is higher, it means it has to decrease to meet the mean reverting level. Is everybody okay with this? Yeah.
No, sorry. Can you take it once? I didn't get the picture clear.
Okay, so what I was saying was that with mean reversion, right? Number one, mean reversion, you're saying that what goes up must come down. That's number one. Or what goes down must come up. So there's a threshold, there's a band. You understand? And that band, we said, is that the average level of potato is 5,000 naira. So if potato price, like, let it go up to 20,000 naira per basket. If it goes up, so if the current price of potato is 20,000 naira, it must come back down to this 5,000. So if potato price is higher than the mean reverting level, right, which is what you're seeing here, if potato price is higher than the mean reverting level, the model predicts that the XT plus 1 will be lower, meaning that it has to come back down to this 5,000 naira. That's why it's saying it will be lower. On the other hand, if potato price is now 1,000, and you're saying that no, there's no way potato price is going to remain at 1,000, which is what you're seeing here. If potato price is below the mean reverting level, the model predicts that XT plus 1 will be higher. It means that it will have to go back up to meet this mean reverting level. That's what it's saying. I don't know if that's a bit clearer.
Yes, thank you. Then quickly, this standard error that is 1 over T. T is what? Is it the T statistic?
No,
the
it's
T,
the it's just the sample.
The sample, okay.
Yes, the sample. Okay, so the next thing is in sample and out of sample forecast. So I have a data set. Right now we're in August. So you have January to August is not even complete. So let's just say we have January to July. Okay. You want to predict what inflation is. So you have your data from January to July. And within this period, you are now forecasting.
Sorry, the standard error is 1 over root T, not 1 over T. But I can see on your slide.
Sorry, root T, please. Let me update it, please. Hold on.
Sorry, I found that it gives the same result.
T over
whether it's 1 over root T or whether it's root T roots 1 over T, it actually gives the same thing.
Root 1 over, sorry, I didn't get that. You know, normally it's always 1 over square root of n or whatever, or in this case T. So what you
yes,
say?
It has to be root n, just like the normal standard error formula.
But I know somebody was saying something. I didn't get what she was saying.
No, I'm saying that I have tried it both ways before, and it has given me the same thing. I've tried
really?
root 1 over n, and I've tried 1 over root n. You can try it and you'll see.
Okay, you are saying,
because I was confused during studying, and it gave me the same thing.
Like this. Is this what you're saying?
Yes, that is the same thing as putting 1 over the square root of n.
Yes, because the square root of 1 is still 1 now.
Yeah. Okay, that makes sense.
Yes, so that's why I said there's no need with the distinction. You get the same thing.
Yeah, but I think what he was saying is that I forgot to put the square roots on the T. I just put 1 over T in my slide.
Oh, okay. I saw square.
Yeah. Okay, so I was explaining in sample forecast. So I was saying that, let's say you have January to July 2024. So your forecasts are within the range of this data. So let's say I have January to July data for inflation, right? And I've developed a new model for forecasting inflation. I want to see if my model is doing well. Let me say, okay, let me just forecast from June to July. So you see, my forecast is within the data that I have. It is inside the data that I have. That is why it's called in-sample forecast. Out-sample forecast in this case now simply means that your data is now outside, your forecast is outside the data that you have. So now I have January to July, but I want to forecast inflation for August. So you can see August is outside the range of data that I have, and that's why you have out of sample forecast. They are made outside of the sample period. The root mean squared error is simply a way of checking your forecast accuracy. You want your root mean squared error to be as low as possible. So if you are comparing model 1 and model 2, the one with the lower root mean squared error, that's the lower forecast error, is basically saying if, for instance, one model forecasted inflation to be 33%, another one forecasted inflation to be 34%, but actual inflation, let's say, is 33.3. So you can see this model has a smaller error. I'll choose this model. That's what my root mean squared error does. Of course, it's not a simple difference, but that's basically the general idea. So you have, the next thing is a random walk, sometimes known as a drunkard's walk. The predicted value of the time series is in one period is equal to the value of the series in the previous period plus a random error. So random walk is just simply saying that, just imagine a drunkard. He's just moving randomly. He has left the bar. He's moving from point A to point B to point C to point D. So he's basically unpredictable. Only God knows what he's going to do. But if there's a random walk with a drift, it means that this drunkard is moving from point A to point B, but no matter what, he will always stop by in his house first to do something. So in between him moving from point A to point D, he will always drift to his house. So that's what random walk with drift basically is. So this random walk itself is just a series that are unpredictable. And the random walk with drift, the intercept term is not equal to 0. In addition to the random error term, the time series is expected to decrease or decrease by a constant amount. So you can see that no matter what, he must go back to his house. Maybe his house is probably point B. So it increases or decreases by a constant amount each period. That's what your random walk with drift is. But one thing to note is that neither a random walk nor a random walk with a drift exhibits covariant stationarity. Either one of them, they are not stationary. At the end of the day, this drunkard is not standing in one place. Whether he's drifting home or whether he's going to point D directly, he is not stationary. He is not moving in a straight line. He's not moving from the bar straight to his house. He's moving from the bar to point B, to his house, to point C, to his house. He's moving up and down. So they are not covariant. He is not covariant stationary. And when something is not covariant stationary, you say that they have a unit root. Okay. So for your unit root test, you can use a Dickey-Fuller test. Again, these tests really exist in all softwares. You put in your variables and then you run a test. It will tell you if it has a unit root or not. Okay, so how do you get your data to be stationary? You do something called first differencing, and this is just like a proof to basically show you how taking the first difference makes your data stationary. I'm not going to go into the proof, but I've just put it in for anybody that wants to go through it when we send the slides, because we don't have time. So seasonality in a time series is a pattern that tends to repeat from year to year. A typical example is Easter. Another example is maybe Christmas. Another example is maybe Salah. So you can say that there's a seasonal trend. Every year during Salah period, there's a lot of sales, like around, maybe you're investigating livestock. So you can say that livestock sales and prices increase during Salah period, it increases during Easter period, it increases during Christmas period. That's what your seasonality captures. So to adjust for seasonality in an AR model, an additional lag of the dependent variable is added to the original model as another independent variable. So you just add another lag of your dependent variable inside the model. Then you have autoregressive conditional heteroscedasticity. Remember what we've said about heteroscedasticity. We said conditional heteroscedasticity is the one that has a problem. And because now you're looking at AR model, that's why it's called autoregressive. That's just why the name is longer. But it's the same heteroscedasticity that we have, that you know, and it's the same heteroscedasticity that you have basically discussed. It's basically the variance of residual in one period dependent on another period. And how do you correct that? You use generalized least squares. The same thing, implication, standard errors are going to be incorrect, is going to lead to type 1 error. The same thing that we have discussed. Co-integration means that two time series that are economically linked and that the relationship is not expected to change. So maybe you have variables like GDP and consumption. GDP and consumption, maybe you can say that they are linked, they have the same relationship. But then if you have GDP itself, let's say, is not stationary, consumption is not stationary, but by the time you put them into the model, they are co-integrated. You can go ahead and use a time series model to do your estimation. Hope that's fine. Then you have your Engel and Granger co-integration test. You can simply now test your variable. Okay, is GDP and consumption, are they co-integrated? You can simply just check. If they are not co-integrated, but then they are not stationary, then you need to first difference each of them. All right. Then a structural change is indicated by a significant shift in the plotted data at a point in time. So just consider a situation where you have data from 1990 to 2024. I mean, imagine the amount of government changes that have occurred between 1990 and 2021. Of course, there are going to be significant shifts. In fact, if you just look at the recent government change, for instance, I'm sure we can see significant shifts. There has been a change in minimum wage. Of course, prices have also changed significantly. So when you look at the series for inflation over this period, you find that maybe from 1980, you find a significant shift. Maybe inflation fell drastically at one point. Inflation shifted drastically at another point. That's basically what structural shift or structural changes are. And typically what you would do is you include what they call structural break dummies in your model. I don't think they discuss structural break dummies in the curriculum though. So this is just a question which we've looked at this. Then which of the following is true of modeling a time series that contains two or more distinct time periods? The optimal data sample period for estimating time series can be calculated mathematically to most accurately estimate time series model. The entire available time series set should be used. We have to feed two different models for each distinct period. Then the second question is which of the following indicates the presence of autoregressive conditional heteroscedasticity? Autocorrelation of the error terms are zero at all lags. The variance of the current error depends on the variance of the lagged errors. The error term shows significant serial correlation at lag 1. I have put the answers for all the questions. We have just about 6 minutes to go. The last thing that we have is machine learning. I don't know if we're going to be able to do that in 6 minutes. But do we have any questions so far? Should we attempt doing machine learning or should we just pause?
Let's attempt machine learning.
Please.
Okay, all right. So
we can
basically,
just deal with the confusion matrix.
pardon?
We can
No,
just
please just continue. Let just anywhere you stop, or to start from beginning.
Let's do this machine learning.
All right, let's look at it. So machine learning is defined as the use of algorithms to make decisions in a given data set. Now, I know it might sound so, intimidating, but it's not really as intimidating. So, your typical regression, you have your dependent variable, you have your independent variable, right? Which are your basically explanatory variables. In machine learning, your dependent variable is your target variable. Remember, it's basically, just think about it, is what you are targeting. I am targeting inflation in my research. My objective is basically to know which candidate performs better in which country performs better in CFA. That is my target variable. That's my dependent variable. My features are basically my independent variable, your explanatory variables. Then the training data set is the sample that is used to fit a model. So you have a data set that you use. Number one, the main point of a training data set is that you want your data to learn. You want to train your model. So let's say I've developed a new model. So what do I want to do? I want to train my model. So I feed in a particular data and say, okay, use this model to learn, Then you now have another data set, which, so this is basically your training sample. Then you have your validation sample. So now after you have used your training sample, so let's say you decided, after I've developed a model for forecasting inflation, right? And inside that model, I put in data set from, let's say, 1980 to 2023 deliberately. I've used that to train my model. Then I now say, okay, let me now use from January 2024 to March 2024. Let me incorporate that to validate my model. So now I've incorporated something new. Okay, because I'm saying that, the economy also significantly changed in 2024. Let me see how well my data can do. So I do that all the way to, let's say, March. Then I now put in another model. All right, now it's time. I want to see, can my model really forecast inflation? As it is now, I don't even know what inflation is in August. So now I throw in data all the way to July 2024. I've trained you, I've validated you. Forecast inflation for me out of sample. Forecast inflation for me for August. Then I wait at the end of August and see how well my model does. That is what the 3 types of sample does. So again, the same thing as you have your in-sample error and you have your out-of-sample error. Your in-sample error occurs with the training and validation sample. Remember, they are within your control. These data sets exist. But your out-of-sample now is outside the sample that is available. Now I'm saying forecast inflation for me for August. August does not exist. So you can see there are prediction errors in the test sample because now I'm testing the model. I'm testing to see if my model is really good. That is what your out-sample errors are. Okay? Then we have supervised and we have unsupervised machine learning. Supervised machine learning basically uses labeled data. So I'm now saying that my target variable is inflation. I've explicitly said my target variable is inflation. I have told my machine learning what that is. But unsupervised learning is that all I do is I put in, for instance, exchange rate, PMS, insecurity. I put all of that inside, but I don't tell my model that the main thing I'm trying to determine is inflation. It's unsupervised. I am now allowing my machine to learn from that data set to try and actually predict what my target variable is. That's what unsupervised learning is. Under supervised learning, you can have your target variable can be continuous and it can be classified. Basically the same thing as we have done your normal linear regression. You can have, remember we talked about logits where you have binary variables, male and female, female candidates. That's the same thing with this classification model. You can decide to have ranking, do I want to do an IPO or do I not want to do an IPO? Those are classification models. Then under unsupervised, you have deep learning algorithms, which again focus on tasks like image recognition. You have reinforced learning, and you have neural networks. Here we have 1 minute. Overfitting is an issue with supervised machine learning that results when a large number of features are used. Remember, like your normal linear regression, you go and overput too many things inside your model. That is going to likely be a problem. That's the same thing with your machine learning. So overfitting the model will decrease the accuracy of out-of-sample forecast because you have put too many things, too many features inside that model. Okay. What time is the next class, please? Is it 2 or 2:30?
2 p.m., ma'am.
2 p.m. So I think I have to pause now because I know the next I'm so sorry I couldn't finish, but this was my last topic anyways.
Thank
You can
you
shoot
so
me an email. I'm happy to chat further. Let me drop my email.
Thank you very much. You're a very good teacher.
You're
Thank
very
you so much,
welcome.
Asana, for taking time out to break down quantitative method. The next class is derivatives, and Fola and Bibola will be taking that class.
All right, thank you. Good luck with your exams.
Hi everyone. Unfortunately, I won't be able to explain all the concepts of derivatives as broadly as Hazana has done with QM. And that's because we have limited time. I would like to just take this 1 hour that we have to focus on just solving a number of questions. And I picked some questions that I think are important. And that's because CFA would not ask you to just calculate the forward price of a derivative. They would they would ask you a question in a way that you would have to kind of task your brain. And the questions are also kind of thought-provoking. So let's just start with looking at the LOS and just gleaning some things from there. Just 1 second. Let me share my screen. Share screen. Okay, can anyone confirm that they can see my screen, please?
Yes.
Thank you. Now, from level 1, when you did derivatives, a lot of the LOSs were more of explain. It was more foundational. Now there's a lot of calculate. Describe how equities, futures, and forwards are priced. Calculate. This is calculate. Calculate and interpret their no arbitrage value. A number of people have come to meet me and ask me, what does no arbitrage value mean? It's very, very simple. So whatever formula that you are given in the derivatives reading, any formula is a no arbitrage formula. Why? Because if if your forward rate is not equal to your the spot price into 1 plus R raised power T, if it is greater than or less than, it means there is an arbitrage. That equal sign makes it a no arbitrage value. So it makes it a no arbitrage value such that with that equal sign, you can't arbitrage based on that formula. So and there are just 2 readings in derivatives, just like level 1, but the 2 readings are very broad and some of the topics can be very, very intense and complicated. But one thing I always tell people is that the ones that seem very complicated, like the Black-Scholes, BSM, Black model, no one is going to tell you to calculate an option based on the Black-Scholes Metin model. You'll probably be asked a question, like just a theoretical question. And that's why all these ones have describe, 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 describe. The calculations are more around the options and the forwards and the different types of contracts. And the other important topic that I found to be in derivatives is the binomial option valuation model. So with that said, let me just quickly go to the first set of questions because, like I said, I want to maximize this time that I have. So let me stop share and share again. Okay. Now let's go to the first set of questions. I took this one from Schweizer. unfortunately, during my time, there used to be a lot of mock questions out there, but now I don't know. It's like everyone has been taken out. So um, I had to put together the ones I could find. So this is from Schweizer. Derek Honey has operated his portfolio management business for many years. Several of his clients have fixed income positions, and one of Honey's analysts has advised that the firm could improve the performance of these portfolios. Honey has begun through swaps. We all know what swaps are. Um, it's an exchange of cash flows. So hold on, through swaps. Okay. Now, Honey knows, oh, Honey knows that the most basic type of swap is the plain vanilla swap. What does plain vanilla swap mean? It just means that you are paying one cash flow like a LIBOR for a fixed rate. So there's a receiver swap, there's a payer swap, and the payer swap pays the fixed rate, the receiver swap receives the fixed rate. So it's all based on the fixed rate. Now, he feels that this would be a good place to begin and enters into a 2-year annual pay vanilla swap where Honey pays LIBOR. Honey pays LIBOR. What does this mean? It means he pays LIBOR and receives fixed. Now, in this case, let me ask anyone if you can help me here. Do you think it will favor Honey when he enters the swap? Do you think it will favor him if interest rates go up or if interest rates go down? What do we think? What favors Honey from these swaps? Yeah, someone said down, down, exactly. So you guys are really familiar with this. Now, he feels that okay, so and Honey pays LIBOR and receives the fixed swap from the other party. To get an idea regarding the swap rate he can expect on the 2 years, he collects market data on LIBOR. So this is the data, this is the discount factor. This is like 1 divided by 1.05, 1 divided by 1.0.06, 1.046 raised power 2. So these are just the calculations from this. Now, Honey knows as interest rates change, the value of the swap positions will change. Suppose that 1 year after inception, the LIBOR term structure is given in figure 2. Where's figure 2? This is the LIBOR term structure after. So this changes every year or changes every period because LIBOR is not constant. LIBOR changes. So your term structure will always change. And this is what the term structure looks like. For every period, you have a LIBOR rate. One of Honey's clients, George Rosen, is aware of Honey's plans to use swaps and other derivatives in the management of Honey's clients' portfolios. Rosen has a position for which he thinks a swap strategy might be appropriate. Honey asked Honey to arrange for him a payer swaption. We all know what a payer swaption is. It's an option to go into a swap. It matures in 3 years. Honey is uncertain of the level of Rosen's familiarity with swaps and swaptions. So Honey wants to make sure that the derivative is appropriate for the client. He asks, blah, 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 and trainer. He also says, okay, we'll come back to all these points, but this is what the question is like. So first of all, which of the following is the least appropriate position to replicate the exposure Honey will get from a 2-year plain vanilla swap? So let me just take out this line first. Then we'll look at it. Right, okay. Now, the question is asking, how can we replicate this strategy if we did not go into a swap? So let's think about it. We've agreed, and all of you know, that the position that Honey wants to take is a receive fixed, pay LIBOR. Now, what does this mean? It means Honey gains when interest rates fall. So we have to look for the option, first of all, that is appropriate for when interest rates for, and we have to look for the one that is wrong. So sorry, we have to look for the option that is appropriate, that honey can use to replicate and gain when interest rates fall, and look for the one that is wrong. So let's look at option A. He plans to take a long series of interest rate puts and short series of interest rate calls. A put is an option to sell, or a put is an option to is like saying that you want interest rates to go down. So an interest rate put favors when you are long an interest rate put, decline in interest rates favor you. Also, short a series of interest rate calls. You are short a series of interest rate calls means you want interest rates to fall. If you were long a series of interest rate calls, it means you want interest rates to go up. That's the first thing you need to remember. Now, the second option is short a series of bond futures. Now, this can be a little confusing because for bond futures, you are entering an agreement based on the price of the bond. So if you are long a bond future, you want the price of the bond to go up. And what's the relationship between bond and interest rates? When the price of a bond goes up, the interest rate of the same bond comes down. So if you are short a series of bond futures, you are short a series of bond futures, you want the price to go down, and it means that you want the interest rates to go up. So this means that option B should be the correct option because option B is not appropriate. The third option is short a series of forward rate agreements. We all know what an FRA is. You know those ones where you see 2 times 7, 3 times 4, and all that. Now, an FRA is you entering an agreement to borrow or to lend at a fixed rate. So if you are short an FRA, you want interest rates to come down. So B should be the answer. Yeah. Now let's go to the next question. Next question is here. Okay. Next question. Given the 1-year and 2-year rates, the 2-year swap fixed rate would be closest to. And we all know that there's a literature in the CFA curriculum, how they derive the formula. But basically, if you have, we have the discount factors, we have the term structure. All we need to do is remember the formula and plug in the numbers. So the formula for this is we have 2 years, it's a 2-year LIBOR. So that means that our Z, remember, I'm not sure, I think I'm using Schweizer. So Schweizer uses the discount factor, calls it the Z factor, but the curriculum calls it something else. Now, our formula is our 1 minus Z2 all over Z1 plus Z2. And we just plug in the numbers, which is 1 minus 0.9158 divided by 0.9524 plus 0.9158. Sorry if you cannot see my writing. Now, if we calculate this, let me see. Where's my calculator? 1 minus 1 minus 8 divided by. Okay, so 1.34. Right. Okay, so you should get around 0.0451, which should be B. Okay, so that's pretty much straightforward. I'll let you go to the next question. Next question is, which of the following, sorry, which of the following is the most likely to be a conclusion that honey would reach? Sorry, which of the following is most likely a conclusion that honey would reach if the payer swaption has the same exercise rate as the market swap fixed rate for the underlying? So how does a payer swaption work? You enter into, it's not a contract actually. You buy a swaption that allows you to go into the swap, and you have an exercise rate which will be predetermined when you buy the swap. And when you get into when the option expires and you're about to start the swap, the exercise rate becomes your fixed rate. Now you that fixed rate is what is effective. That is what you use to kind of implement the swap. The question is asking, what conclusion would honey reach if the payer swaption has the same exercise rate as the market swap fixed rate? Now let's look at this. You have a situation where the exercise rate is equal to the forward rate of the swap, or the exercise rate of the swap. So the forward rate of the swap, which is the fixed rate. Now, if this is the case, both the payers side of the agreement and the receiver side of the agreement will be equal, because they will both be at the money. They will both be at the money. And that's because you have a situation where the exercise rate is equal to the at market forward swap rate. So both will have to be at the money. They will both have the same value. Now, so option A, the payer swaption will be out of the money. No. So this will not be the case. The value of the payer swaption would be the same as the value of an otherwise identical receiver swaption. This should be the correct answer. The payer swaption will be more than an otherwise identical receiver swaption. So this will be wrong. Now, the reason why, so the thing to remember here is that both the what's it called now? The exercise rate and the market swap fixed rate are the same. So there's really no difference between the receiver swap and the payer swap in this case. So both of them will have the same value because they will both be at the money. Now let's go to the next question. Sorry. Hold on. So the next question is, for this question only, assume that the swap fixed rate is 4.5% and the notional principal is 1 million. Based on the information in figure 2, the value of the swap to honey is closest to. So let's look at figure 2 again. Well, actually, I'm supposed to do this. Sorry, I'm just trying to see if I can bring this here. Okay, so this is what we have as figure 2. And the question is asking, what will be the value of the swap based on the information on figure 2? Now let's look at this question. So it's a 2-year swap. It's a 2-year swap. 2-year swap. This is 1 year into the contract. So this is 2 years. This is 1 year into the contract. Now, Honey wants to know the value of the contract at this stage. Now, at time 1, so this is where we are, year 1. At year 1, you have your discount, you have your LIBOR. Your LIBOR rate is 4.88%. Now, it's a swap. The fixed rate is 4.5%. Remember, a swap is an exchange of cash flows. Now, Honey is, I think, is Honey paying LIBOR? Honey is paying LIBOR. So what will happen is the value of the contract will be minus 0.045, which is what Honey is paying, which is coming out of Honey's pocket. Sorry, minus 0.048, which is what Honey is paying. Now he receives the fixed rate of 0.045. Now this is pretty much straightforward. This is the easier part of the answer. You are receiving a cash flow from the swap, you are paying a cash flow. Now, the discount factor. Our discount factor here is 0.935. This 0.9535 is similar to you just discounting by saying multiplied by 1 over 0.048. So this 1 over 0.048 is this 0.9535. So all you're doing is just discounting it by this discount factor. Now, you then multiply it by 0.9535. Okay, that's the next step. The other step is you have to prorate it. Well, it's an annual swap, so you just multiply, so it's the same as 1. And then so times 1 million. Okay, so that's what you have. You have the cash flows from the swap, paying 0.048, receiving 0.045. Discount it, you are discounting it by this discount factor because you have 1 year left to the contract. So you have to discount it from here back to here. Okay. Now, if, for instance, you had 2 years, like it was a 3-year contract and you were at time 1, you would discount it by the 2-year discount rate. So, but now we are looking at a 1 year period. So we discount it from year 2 back to year 1. That's why it's 0.9535. And then with all this calculation, you should arrive at minus 3623, meaning the other side of the swap contract receives 3626 net. So the net loss to Honey is 3626. So A is the answer here. Let's see if people are still here. Please, can you explain question 1 again about the bond futures? Oh, okay, sorry. I missed this question. Let me quickly, what's the time? Okay, let me quickly go back to question 1. So the relationship between, what I was just trying to say was, the relationship between a bond price and the interest rate on the bond price is inverse. So there's an inverse relationship between a bond's price and the bond's interest rates. So the interest rates, the effective interest rates from the bond, there's that relationship, such that if you buy a bond, you want interest rates to fall, because if interest rates fall, the interest rate on your bond would fall and the price of your bond goes up. That's just what I'm saying. So the question is saying which is least appropriate. If you are short a series of bond futures, it means you are selling bond futures. It means when you are short, normally when you are short, you want prices to go down. When you are short a futures or a forward contract, you want prices to go down. Now, the bond price, if you are short a series of bond futures, the price comes, and the price comes down. It favors you. But as the price comes down, the interest rate goes up. Now, in the context of this question, it's asking that which is the least appropriate position to replicate Honey's exposure. Now, Honey's exposure, when we replicate, we're trying to get a similar kind of position that Honey has. Now, Honey, what favors Honey right now is if interest rates go down. Now, if interest rates go down in this case, it does not favor someone that is short a series of bond futures. Why is that? Because if you are short a series of bond futures, you want the price of the futures to go down. Now, if interest rates go down, the price actually goes up. So if you are short a series of bond futures, you would lose here. So it doesn't favor you. Rather, if you were long a series of bond futures, the interest rate decline would favor you. So that's just what I'm trying to say. I'm going to quickly go to the next question because there's still a lot of questions I need to cover. Yeah. Right. The next question is, which of the following is least appropriate motivation for a covered call strategy? So let's think about it. What is a covered call? A covered call is you are long the underlying assets and you now underline, so let's say it's a stock, underlying shares of a company. Let's assume. You now take those shares and you sell a call. You sell a call at a particular strike price, at a particular exercise price, which I'll call X. So this is what a covered call is. And the major reason why people do this is for income generation, meaning when you sell a call, when you sell the call, when you do this part of the strategy, you are receiving some income from the premium. Target price realization. Now, I'll explain this target price realization. You sell a call, you have some shares. Let's say you buy shares at $3. The shares goes to $6. It rallies to $6. So this is $3. It goes up to $6 in a few years. Now, you then say, okay, you know what? I have a target price for this stock. Let's assume I want to sell this stock at $6.50. So what happens? You can sell a call at a strike price of $6.50, as an exercise price of $6.50, such that when the price, remember that a call is a maximum, the value of a call is a maximum of our price of the security minus the exercise price. So what happens when the price of the equity reaches our $6.50, we sell at $6. So we can use this $6.50 as our target price, meaning that this is the exercise price that once the price of the underlying gets to $6.50, it gets exercised and you sell the shares at $6.50. Lowering the target price is not an appropriate motivation. So C is the answer here. So C is the answer here. Now let me see. I'm seeing a lot of chats, so I'm guessing I have a lot of questions. Can you please explain question 4 again? Can you explain the C? So let me start with the MC. Can you explain the C? The C of what question, please? C of question 1. Okay. So I'll start with EMC, then I would I'll look at question 4 again. So let me just erase all this. Is there a way you could just erase all? I'm sure there should be. This takes time. Okay. The C part, a series of forward rate agreements. So this is quite straightforward in the sense that when you enter a forward rate agreement, um, there is a forward rate. So there's a forward rate. Now you can be long or short a forward rate agreement. So think of it like a forward contract on anything. So let's assume let's assume it's not a forward rate agreement. Let's assume it's a forward contract on something else, and you have a forward price. Now, if you are long this forward contract, you want prices to go up. If you are short this forward contract, you want prices to come down. Now, if you are short a forward rate agreement, you want interest rates to fall. If you are long, you want interest rates to go up. And let me just quickly explain the rationale behind this thinking. So let's assume it's anything. Let me say my pen. The forward rate, we agree that the forward rate of my biro or my pen is $5. And I am long a forward contract of $5. If in a year's time, the market price of my biro becomes maybe $6, what can I do? I can buy at this $5 and sell at $6. Now let's assume it's the other way. Let's say I'm short. Let's assume that now I am short and our forward price is still this $5. And for some reason, the price declines. In a year's time, the price declines to $4. What can I do? I can sell at $5. Remember, because I want it to go down, I am favored here. I can sell at $5, come back here and buy back at $4, meaning I make a $1 gain. So basically, that's what it is here. You want the interest rates to come down, and because it's similar to the position that honey is in, it means that it is not the correct answer because it is not the least appropriate position. This is the least appropriate position. Sorry, it is not the least appropriate position. This is the least appropriate position. Now let me go to question 4. Okay, let me go to question 4. Question 4. So now, um, we have a swap here. He has entered into a swap, a 2-year swap. What is a swap? A swap involves the exchange of different cash flows to achieve a purpose. So this is 1 year. This is 2 year. Now, sorry, this is a 2-year swap. Now, honey is at the 1-year swap. The fixed rate from the swap, from the question, the fixed rate is 4.5%. Remember, for a swap, for an interest rate swap, you can have fixed for floating, you can have different kinds of swaps. So this is a fixed for floating swap or a floating for fixed swap. We've determined that the fixed rate is 4.5%. And we are at year 1 here. This is where we are. We want to value the swap. We are valuing the swap. What is the value of honey's position? What do? We look at what the discount. What was that? We look at what the discount, sorry, what the LIBOR rate is at year 1. The LIBOR rate at year 1 is 4.88%. We then use this to value the swap. So what do? If this was, so let's even start with the 2-year swap first. Let me not confuse anyone. So now what's happening? In this case, now honey is paying 4.88%. Remember from the question says that the swap arrangement involves honey paying LIBOR. So honey is going to pay LIBOR of 4.88%. And so he's going to pay LIBOR, he's going to pay 4.88. He's going to get 4.5%. So this is leaving him his pocket. This is coming back to his pocket. But then you have to discount the LIBOR. You have to discount the LIBOR because the cash flow is going to happen at year 2. Sorry, the exchange of cash flows is going to happen here at the end of year 2. Now, you are at year 1. You have to use the discount factor of year 1 because you only have 1 year left for the contract. So you have to discount it using the 0.9535. If it was a 2-year or 3-year contract, you can use, so if it was a 3-year contract, for instance, you would use another discount factor. But because we are at year 1 and the contract ends at year 2, we have to discount it using the 1-year discount factor. So that's why we multiplied by 0.9535. And we know that the notional principal is 1 million. We then multiply by 1 million. So that's what it is. Okay. So that's what that's all about. I'm just gonna go to the next question. And I don't know, maybe after if you need any other kind of guidance or you're still confused on certain things, you can reach out to me maybe during the week or next week, and or maybe reach out to me on LinkedIn and I can help explain better. But because of time, I can't really spend time on one question. So let me go to the next question. Okay, we've done this. Okay. The gamma position of a covered call strategy is most likely to be what? We all know what a covered call strategy is. A covered call is long on the line, short call. Now, we know that for the long on the line, so let me write this. You have long, so you're long the underlying assets, and you are short a call. So what is a gamma, first of all? Gamma measures the rate of change of options on a data on an underlying asset. So what does that mean? A gamma is it measures the rate of change of of the options delta. So of the options delta. So it measures how the option delta changes as the underlying asset prices changes. So as the underlying asset prices changes, it measures the way the option delta changes. And what is option delta? Option delta measures the rate of change of the option price against so the option price against the underlying price. That's what so gamma is like a second degree measurement of delta. Now, what are they saying? The gamma position of a covered call strategy is most likely to be what? First of all, what is the gamma position of a stock or an underlying asset? The gamma position of an underlying asset is 0. And that's because the delta of an underlying asset is always 1. So the delta never changes. The delta is always 1 because for every rate of change of the asset, the delta will always be 1. So it's 1 because as the price changes, the return you get so it's commensurate to the return you get is commensurate to the rate of change in price. Now, your delta is 0, so your gamma for the long underlying stock would be 0. Now, when you are short a call, it means you are negative gamma. When you are long a call, it means you are positive gamma. And there's a literature on it, and there's a way it's proven and all. But when you are short a call, you are negative. It means your gamma is negative. So net, you have 0 gamma on the underlying, you have negative gamma. So the gamma position on this strategy is negative, which is B. Okay. Now we're done with this. I have another set of questions. I'm not sure um we'll be able to finish all the questions I have, but I really want to talk about this question on binomial valuation because I believe it's very CFA places a lot of importance towards it. So the next set of questions is here. Okay, now I'm not going to read through the question word for word. So this is our tenor advisors, manages positions and all. He says, I'm somewhat familiar with options valuation models. We have we have different valuation models, but the ones that CFA stresses are the binomial valuation and the Black-Scholes model. The binomial valuation can be applied to this. This is all the things, the inputs of the binomial valuation. This is the index price and all the strike price, head ratio. Now, there are so many things here, explains this and that, and different things, but we'll look at each and every one of them as we're going through the questions. So the first one is, Using the binomial valuation method and data in Exhibit 1, the price Mesa paid for the call option with a strike price of 750 is closest to what? Okay, so let's look at the exhibits. So what I can do is, let me see if I can just okay. So this is the table we have here. And now what they're asking is, this is a two-stage binomial valuation. Why is it two-stage? Because it's a 2-year. Let's look at the question. It's a 2-year European style index call option. So it's a 2-year call option. So it's a two-stage binomial model. And we start from the first stage. So the first thing to do is, what is our up factor and what is our down factor? Now, our up factor here is 1.15. Our down factor here is 0.09. They've calculated the risk neutral probability, which is 0.52. So we have all our inputs here. So we start from the base year. The base year, we have our S0 index price is 720. Now, when the price goes up, S1 plus is 720 multiplied by 1.2, because this is, sorry, 1.15 actually, because this is our up factor. Our U is our up factor. So multiplied by this by 1.15, we get 828. Now, if this was a one-stage binomial valuation model, we would have calculated the price of the option here. Would have said 820 minus 750 to get our option, our call price, but it's a two-stage. So now the next stage is to get our S1 minus, which would be 828 multiplied by 0.9, which should give us 648. So this is the first year. This is year one. This S1 minus. This is year one. Now year two, we do the same thing. We have 828 multiplied by 1.25. So the up factor from year one to year two becomes 952.2. In this case, because it's a 2-year valuation model, we stop at year two. Now we calculate the call price here. The call price here. Remember, our call price is maximum of ST, which is the price of the underlying, minus our exercise price, or 0. This is the call price. Remember this. So in this case, we say 952 minus what's our strike price? Our strike price is 750. So 952.2 minus 750, which should give us, so our C2 plus should give us 202.20. Here, so our this is S2 minus from here. So this is S2 plus. S2 minus is 700. So this is 828 times 0.9. This is 745. This is the price of the underlying. Now, our call price here, C2 minus, here is 0. Why is it 0? Because 745 is lower than the strike price of 750. So this is 0. We can do the same thing here as well. Let me just erase this part. We'll do the same thing here. So you have for 648, I don't want to confuse. So this is, let's move down here. 648 here. From 648, you go up here. So 648 times 648 times 1.15 would give you this 7.745. 648 times 0.9 should give you 583.2. In all these cases, our C is 0. So the value of our call is 0. Why? Because they are all lower than 750. So we all have, so we only use this 202. Now, the next step is to use this option value to calculate the option value at S1, at this period, at period 1. So what do? We remember the formula which says that pi into C plus 1 minus pi into C minus divided by our risk-free rate. So discounted by our risk-free rate. So what do? We just plug in the numbers. So this is, we have, hold on, let me erase some things here. So you have, what is our pi? Our pi is 0.52 multiplied by 202 plus, this is not relevant because it's going to be 0, but this is, what's 1 minus 0.52? 1 minus, so this is 0.48 multiplied by 0 divided by 1, divided by 1.03. So it's divided by 1.03. Now, when we calculate this, we should arrive at, we should arrive at, sorry, we should arrive at 51.53. Sorry, hold on. Not 51.53. We should first. So what happens? We take it from here to here. So here, the value of our option is one. What's happening? Oh, what have I done? Okay, so the value of our option here is 102.0816. So this is from this calculation. So this is from this calculation. We get 102.0816. Now we have to calculate the value of this option at time 0. We then apply the same formula again, which is 0.52 into 102.0816 plus 0 divided by 1.03. Now, if we do the calculation, we should arrive at, sorry, we should arrive at 51.53. So basically, for simplicity, what we do is we draw the binomial period lines. We calculate the call option values. So we bring it from period 2 to period 1, which is why we got 102.0816. We then discount again and bring it back to the period 0 using that formula, this formula here, which is this. So that's how we get 51.53. Let me see if I can squeeze in one more question. How did we get 202.2? We got 202.2 by saying 952.2 minus 750. Minus 750, sorry. Yeah, so that's how we got the 2.202. Yeah, 1.15, not 1.25, sorry. This is 1.15. So the next question is I'll just try and do one more question and call it a day because we don't have time anymore. Hmm. This will come here online. Okay. With respect to his assessment of replicating the option payoff, Zilat is least likely correct about what? Let's go. Least likely correct. So let's look at what he says. Sorry, I'm just trying to get where they're talking about. I'm somewhat familiar. I like to learn, blah, 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 blah. Okay, so of course, with the index moving down 10% in the last 12 months, the payoff with these options could have been replicated without using options. My understanding is that the payoff would have been the same as the call option if you had purchased 0.5697 index units and lent 3567.79 at the 1-year interest rate. So this is the comments they are talking about. Now, what they are saying is it correct? Which of the sentences are correct? So would he be correct if he lent? So they're asking is, how do you replicate this same option payoff? How do you replicate this option payoff? The first option is lending 3556.79 using the 1-year interest rates, purchasing 0.5697 index units. We're out of time, so and it's going to take a while for me to explain this. So I don't know. I think yeah, so if you have any questions or if you have any queries, you can contact me on LinkedIn or you can get my contacts from the CFA Society. I think I'll just call it a day here. Have a good evening, everyone, and good luck with your
Thank Thank you so much for your time, Fola. We really appreciate it. Thank you, everyone. This brings us to the end of today's session and also to the end of August 2024 CFA Level 1 and 2 Revision Bootcamp. Our gratitude goes to our facilitators who made the sessions possible, our sponsors, New Frontiers Learning Center, Brighton Business School, and First Quartile Professionals. Our attendees for paying rapt attention, and the Society Office for dedicating their time through the weekend. The slides and materials will be sent to all registered participants via email. Do have a lovely day further. And on behalf of CFA Society Nigeria, I wish everyone the best of luck in the exam. Bye.